yesterday's concept, right? So we have discussed about the one of the memory component of a shared memory areas, which is a shared buffers. Okay, today's topic is val buffers. So today's topic is val buffers. Okay, what does it mean by val buffers, right? Val buffer is a buffer which holds val data. So val buffer is a buffer which holds val data. What does that mean by val data? Val data means, okay, so whenever you do any transaction, whenever you do any transaction, whenever you do any transaction, what happens? Actual operation is going to happen. Actual operation is going to happen where? Actual operation is going to happen in shared buffer. Okay, actual operation happens in shared buffers. Okay, shared buffers, the actual update or actual operation is modify operation is going to happen in shared buffers. Okay, shared buffers. Whereas, okay, metadata about the transaction, okay, metadata about the transaction will be stored in metadata about the metadata about the transaction is stored in val buffer. Okay, metadata about the transaction is stored in val buffer. So today we are going to discuss about this val buffer. So this actual operation is going to happen in shared buffers, whereas metadata about the transaction is stored in the val buffer. Okay. So whatever the data, okay, whatever the data that is stored in val buffer, we call it as a val data. Whatever the data that is stored in a val buffer is called as a val data. When I say data, actually it is not a data, it is a metadata about the transactions. Metadata about the transactions. What does it mean by metadata? Metadata is nothing but data about data. Okay, so when you perform any update operation, actual update is going to happen where? Actual update is going to happen in a shared buffer, whereas information about that update statement, okay, information about this update statement is going to get stored in val buffers. Whatever the data that is getting stored in val buffers, we call it as a val data. Got my point, right? So val data is nothing but the information about the transactions or metadata about the transactions. What is the purpose of this val data? So what is the purpose of this val data? The purpose of this val data is, so val data is used for the instance recovery. Okay, val data is used for what? Instance recovery. How it is going to perform the instance recovery, that we are going to see it in a while. Okay, so val data is responsible for performing the instance recovery. How it is going to perform the instance recovery? Now see, let's say, so I have a user u1. Okay, I have a user u1 who connected to the database. Okay, I have a user u1 who connected to the database and performed some update operations. Okay, perform some update operations. This operation started at 9 a.m. Okay, this operation started at 9 a.m. IST. Means it started our time 9 a.m. Okay, then what happened at 9:30? So this update operation has been completed and he gave a commit. Okay, and the update operation is completed and he gave a commit at 9:30 a.m. IST. 9:30 a.m. IST, he gave a commit again. Again the same user has started one more update operation. Okay, one more update operation at 9:40 a.m. IST. So again user u1 has started one more update operation at 9:40 a.m. IST, and in between what happened, right? At 9:45, okay, at 9:45 a.m. system is crashed. Okay, system is, what happened? System is crashed. Okay, what happened at 9 a.m. He started one update operation, it is completed at 9:30 and he gave a commit. Okay, he gave a commit, and at 9:40 he started the update operation, but 9:45 what happened? That system is crashed. Okay, if you remember, whenever you, so if you want to try to bring up the system again, okay, if you want to try to bring up the system again, then the what is the process that is responsible for performing this instance recovery is a postmaster. Okay, about this we will be discussing in next session. Okay, postmaster is a process which is responsible for performing the instance recovery. Okay, instance recovery. Okay, whenever you try to say, whenever you try to boot up the system, then the postmaster checks for the latest commit or checkpoint. Okay, postmaster checks for the latest commit or checkpoint. At what time we have a commit or checkpoint? At 9:30 a.m. we have a commit or checkpoint, which means if you remember when we were discussing about the shared buffer, we have seen that background writer is a process which is responsible for writing dirty data from shared buffer to the disk in the event of commit or checkpoint, or one third of the shared buffer is filled. Likewise, whenever you try to bring up the system, it checks for the latest commit or checkpoint information. Why it has to check for the latest commit or checkpoint information? Why it has to check, right? So whatever the data that is there till this checkpoint is persistent, which means it has been already in the disk. Okay, the postmaster process has to worry about the transactions that are happened between the latest commit point to the till this time, right? So whatever the data that whatever the information or whatever the modification that are happened till 9:30 is already there in the disk, because at 9:30 they gave a commit. Okay, so the postmaster, for instance recovery, the postmaster has to the postmaster has to worry about the transactions that happened between 9:30 a.m. to till this point. So while for performing this instance recovery, postmaster is going to use the val data. So postmaster is going to use the val data. So as I said, like val data is information about the transaction. So whatever the transactions that are happened between 9:30 a.m. to till this time, those operations will be re-executed by Postgres, re-executed by postmaster process to perform the instance recovery. Those operations are re-executed by the postmaster process to perform the instance recovery. This is how, okay, this is how a val data is used for performing the instance recovery. And what is the parameter related to val buffers? Val underscore buffer is the parameter. Val underscore buffer is the parameter which is related to the val buffer. So how can we increase, how can we decrease, that we will be seeing it in our next sessions. Okay, the next is, what is the default value? 64 MB is the 64 MB is the default value. 64 MB is the default value. And next thing is, so val writer. Okay, val writer is a process. Okay, val writer is a process. Val writer is a process which is responsible for val writer is a process which is responsible for writing. Val writer is a process which is responsible for writing val data from val buffer to the val writer is a process which is responsible for writing val data from val buffer to the disk. Okay, when I say disk, we call it as a val files. The location where it is going to write is pg underscore val location. No need to worry about all the locations and everything, because these things we are going to discuss it in the directory structures of a Postgres system. Okay, so val writer is a process which writes this val data from val buffer to the val writer is a process which is responsible for writing val data from val buffer to the disk. Okay, more about the val writer we will be seeing it in the process based architecture. The next memory area, that our next memory component of the shared memory areas is clog buffers. Okay, clog buffers. The next memory component is clog buffers. Okay, what does it mean by clog buffer is, right? The clog buffers are maintained by Postgres system itself. Clog buffer is maintained by Clog buffer is maintained by Postgres system itself. So what is the purpose of this clog buffer is? Clog buffer stores state of the transaction. Clog buffer stores what? State of the transaction. So the state of the transaction can be what? The state of the transaction can be in progress, cancelled, aborted, or stopped. Anything. Okay. So do we have any parameter to increase or decrease the values of clock buffers? No. The Postgres itself is going to maintain the clock buffer area in a tiny amounts. So this is about the clock buffers. With this, we have completed the memory components of a shared memory area. So we have discussed about the Wal buffer. We have discussed about the shared buffer, and we have discussed about the clog buffers. Now we will be discussing about the components of the local memory areas. What does it mean by local memory area? Local memory area is a memory area which is local to the process, which is private to the process, which means only that process can access this memory area that is allocated to it, whereas other processor doesn't have a visibility. So what is the purpose of this local memory area? Local memory area is used to store the information about the state of the process and PID of the process. It's also used for its internal operations. Okay, this local memory area is a local or private to the process. Okay, private to the process. Now what are the different components of local memory areas? The different components of local memory area is, one is work memory, second one is temporary buffers, and third one is auto vacuum work memory. Third one is auto vacuum work memory, and fourth one is maintenance work memory. Maintenance work memory. So we need to discuss about all these topics. Once we are done with all these topics, we will be completing the memory architecture of the Postgres system. So now for today, let's start with the work memory. So what does it, here we are going to discuss what does it mean by work memory, what is the purpose of it, and what is the designated parameter to increase or decrease the work memory area, and so what are the limitations for increasing the work memory area. Those things we will be discussing about, okay. So work memory, so what does it mean by work memory, right? Okay, work memory is a local memory area, right? So when I say local memory area, each and every process will be assigned with this work memory. It is not a common memory area which is accessed by all the background process. It is a local to the process, or it is a private to the process. Okay, so this work memory, okay, this is also a RAM based memory area. Okay, whatever the value that we define using a work memory parameter, that will be taken from the RAM only. Okay, RAM based memory area. All the memory component that we have discussed so far is a RAM based memory area. So whatever the value that you have defined using that particular parameter, that will be taken from the RAM only. What is the parameter related to work memory? Work underscore mem is the parameter. Work underscore mem is the parameter. And so what is the purpose of this work memory? Okay, so if your SQL query, so let's say you connected to a database and you have filed a SQL query, you have executed a SQL query which contains join, group by, and order by operations. Okay, which contains join or group by or order by operations. These operations are going to happen in which memory area? Whenever you execute a query and your query contains join or group by or order by operations, those operations are going to get performed in work memory. Those operations are going to get performed in work memory. Okay, if the work memory is not enough, if the work memory area, okay, if the what is the default value of this work memory? The default value for this work memory is 4 MB. Okay, if the work memory is not enough, if the work memory is not enough to hold the operations, okay, whatever the intermediate operations that we have discussed, like join or group by or order by, those operations are going to happen in work memory. If that work memory area is not enough to hold the operations, then the operations will spill onto the disk. Okay, then the operations will spill onto the disk. How do we know that operations are spilling onto the disk? Whenever the operation is spilled onto the disk, on the at the operating system level, we could see .tmp files are getting created. So let's say there is a query that is running from a particular session, and you are seeing that there are .tmp files that are getting generated at the OS level, which means whatever the work memory area that we have, whatever the work memory that we have assigned is not enough to hold the intermediate operations. And so as purpose of that, the operation is spilling onto the disk to indicate that .tmp files are getting created on the OS level. Okay, what is the lifetime of this .tmp files? Okay, once the session is executed, these .tmp files will be dropped automatically or will be deleted automatically. The lifetime of the .tmp files is limited to that session. Once the query is completed, those .tmp files will be removed or dropped automatically. Okay, so let's say I am running a query which contains, as I said, like join and operations or group by operations, and if my work memory is not enough, as the operation is going to spill onto the disk, the time it will take for executing a query increases. When the query execution time increases, the performance of a query will decreases. Okay, the performance of a query will decreases, but there is a caveat here. Okay, so you should be very careful. Okay, you should be very careful while assigning the work memory value. What is the default value for this work memory? The default value for this work memory is 4 MB, but if you want to increase, you should be very careful, because each and every session, okay, because each and every session will be assigned with the value that is defined using a parameter called work underscore mem. Let's say I have like 100 connections to my 1000 connections to my database. What is the total utilization of the work memory? Total work memory utilization equal to total work mem utilization. Okay, total work mem utilization equal to number of sessions into each session will be assigned with the value that is defined using work memory parameter. In my case, what is the value of work memory parameter? 4 MB. Okay, 1000 into 4 MB, which is like 4000 MB. It is almost equal to the 4 GB. Okay, so it is 4 MB is fine. Okay, let's say if you give like work memory as a 1 GB and you have 1000 sessions, all are performing the same query, then each and every session will be assigned with the value that is defined using work memory, which is like 1 GB. 1000 into 1 GB, 1000 GB, it is almost equal to 1 TB. Do we have any system which does we have a does is this a feasible solution to have a system with 1000 GB of RAM? No. So that is the reason why we should be very careful while assigning the work memory, while increasing the work memory parameter. This is about the work memory. So the next memory component of a local memory area is temp buffers. Okay, the next component of a local memory area is temp buffers. Okay, so temp buffers, right, in Postgres. Okay, in Postgres there is a concept called temporary tables. Okay, there is a concept called temporary tables. Not only Postgres, in every RDBMS I think we have the concept of temporary tables. Okay, so what does it mean by temporary table? What does it mean by temporary table is, temporary table is a table which is used to hold the intermediate operations. Okay, do we use the temporary tables? As a DBA, we don't use the temporary tables. Okay, temporary tables are being created and used by the developers to store the intermediate operations. What is the lifetime of this temporary table? Okay, lifetime of the temporary tables is, lifetime of the temporary table is limited to the session. Lifetime of the temporary table is limited to the Lifetime of the temporary table is limited to the session, which means once you disconnected temporary table will be dropped automatically. Temporary table will be dropped automatically. Okay, the temporary table is temporary to the session. Once you disconnect from the session, the temporary table will be dropped automatically. Okay, so what is the purpose of temp buffers? Okay, if you perform any operation on this temporary table, the temp buffers will be used. Okay, if you perform any operation on this temporary table, then the temporary buffers will be used. What is the parameter related to the temporary buffers? Temp underscore buffers is the parameter. And what is the default value? The default value of this parameter is 8 MB. Okay, if you the straight away point is, if you want to perform any operations on these temporary tables, temp buffers will be used. The default value for the temp buffers is 8 MB, and if you want to increase, you can increase this temp buffers by using temp underscore buffers parameter. How can we increase? What is parameter? How can we see the value? And all those things we will be discussing it in the concept of parameter file management. Okay, concept of parameter file management.